Hello, hope you're enjoying this video. As you see, a normal takeoff here. The point here is to, though the center line is not really in view, but you can see where the yellow arc is showing. And you see it's passing below the middle instrument. During takeoff run on ground, we are monitoring the airspeed. At proper airspeed, we smoothly initiate the rotation. At V1, smooth and continuous rotation at a rate of 2 to 3 degrees a second, up to 12 degrees pitch up. Fast rotation can lead to a stall or stick shaker, as you see in the video. The primary instrument during rotation is the artificial horizon. Continuous rotation 2 to 3 degrees per second, up to 12 degrees pitch up, and then we look outside and assign the reference point relative to the horizon on our screen. Focus now on the airspeed indicator. The primary instrument now after the rotation is the airspeed indicator, and you adjust your nose attitude to climb at the required speed. At 500 feet, we start left turn. Control column, rudder. We started the turn, and if you notice that the aircraft pitched a little bit down, so you need to correct that. In the 1000 feet, we level off. And see, because we lost our reference point, the reference point went up, the horizon went up and down. See how the altitude, rate of climb changes and altitude changes. This is all because of the losing of the reference point. Gradual reductions of power and pitching down, leveling off, checking the vertical speed, and slowly maintaining the 1000 feet altitude. Time to turn to the downwind leg. Applying aileron, rudder, a little bit of power because of the drag created, and a little bit pitch up, and maintaining the rate 110, which is about 15 degrees bank angle. Exiting from the turn is the same process. Again, aileron and then rudder, reducing the thrust or the power of the engine, and pitching 2 to 3 degrees down to maintain the altitude. And horizontal reference point as an object, mountain or anything. So if you look at the green arrow here pointing to this mountain, so the object is reference to your screen. So this is the horizontal reference point. Checking your position related to the departed runway is a part of situation awareness and being ahead of the aircraft. Trim is very important to reduce the workload. It really makes your life easy. Leave the control column, see if the aircraft pitched down or up. Refer to horizon, vertical speed, just to make sure that you are on the right trim. As you see now, we are in a downwind leg. The airplane is fully trimmed in a straight and level with a 0 force on the control column and a steady speed of 80 knots. Now we can revert to the power trim corrections. Any correction in the altitude can be achieved with the power. Small increase in engine RPM will lead to little climb or small climb. Trim will affect the speed. Time to turn base leg. First is extend the flaps, lower the engine RPM, and start the turn. Descend 300 to 500 feet per minute. There are few facts when you fly visually. Fact number 1, you know you're going to a point when this point is affixed in relation to your screen, which means it does not change its position relatively to your screen. In other words, if you're aiming to a certain point, you remember the point position on your screen. See the green arrow? If this point drift left tells you that you are going to the right of that point, and if the point drifts to the right, it tells you that you are flying to the left of that point and you should fly right. Fact 2, trim reduce the pilot workload. Pilot should always trim the aircraft except during the flare. And the aircraft is trimmed when zero elevator force on the control column.